9.7 Similarity. All right, 4 vocab words that you need to get into your notes. Similar, and that's the sign for similar. Who remembers the sign for congruent? It was the similar sign, but what was under it? Yep. That's the congruent sign. Similar figures, so by what we just wrote down in our notes, similar figures have the same what, but not necessarily the same what? The same shape.
And size.
Yep, and size, but not necessarily the same size. Like yesterday, our dilations were similar. They have the same shape, but not the same size. Corresponding line segments in the figures are what? There's the P. R. What is it? Yep, proportional. Corresponding angles then in the figures have the same what? Such as an M. Measure. Nice. So in similar figures, the sides are proportional, and the angles, no matter what you shrink it or enlarge it, they have the same measure. The angles always stay the same. All right, looking at example number 1. It says, complete the dilation about the origin using a scale factor of 2. So what we learned yesterday was the first thing that I have to do then in order to do a scale factor. First I have to find the ordered pairs of what? Yep, of the pre-image. So what are the ordered pairs of A? Right here I have it written. The ordered pairs for A are 2, -3. The ordered pair for B is 1, -3. The ordered pair for C is -2 and 1. Now, what do I do to these originals? Yep, multiply in this case by 2, because 2 is our scale factor. So multiply each and every one of those numbers, those x and y coordinates, times 2. So our new A prime will be what? -4, -6. Each one of these times 2. And that's what you get. So what's B prime? 2, -6. C prime, -4 and 2. Now we need to go and plot our new image on the graph and label it, please. -4, -6. Our new A prime. 2, -6. Our new B prime. And -4, 2. -4, 2 is our new C prime. All right, now using your straight edge, create your new image. It should look like that. A dilation with a scale factor of 2. So now looking up at this graph, let's answer the questions below. What is the length of side AB? What is the length of side AB? Are we looking at the original though? Is this the original or the prime? The original. What is the length of side AB? So we're looking at this one right here. How many units? 3 units. What is the length of AC? 4 units. What is the length of BC? Can we just count the units on that one? No. Who remembers what I can do if I have my A and my B in a right triangle. If I have two sides of a right triangle, how can I figure out the third side? We did this earlier in the year. What do we use?
Pythagorean theorem.
Oh, I didn't even prompt you on that. So proud. The Pythagorean theorem, and what is that? They're right there. So we take our A squared, which is 3. Because do we have our A and our B or our C on this one? Which two do we have out of our A, B, and C? We do. We have the two, what are they called? The two sides that make up the right angle are called our legs. The A and the B are our legs, and those are the two that we have. They are the 3 and the 4. So 3 squared plus 4 squared equals C squared. What is 3 squared? 9 plus 16 equals C squared. 25 equals C squared, so is my answer 25? No. I need to find the square root of all of this. What's the square root of 25? 5. What's the square root of C squared? C. So 5 equals C. So what is the length of BC then? Right here? We just figured it out. It is 5 units by using the Pythagorean theorem. So now going to the prime triangle, what is the length of the side of prime AB? Oops. There we go. 6 is exactly right. What is the length of side AC?
8.
8. So, do I need to do the Pythagorean theorem to figure out BC? Again? No, why not?
You have times by 2.
Yeah, did you guys notice that? It was a scale factor of 2, so times 2 equaled my 6, times 2 equaled my 8. So do you think times 2 that this will be, this side here will be 10 then? Who thinks yes? And drum roll. Voila. So you only have to do the Pythagorean theorem for the one pre-image and then either multiply it. If you want to, you can do the Pythagorean theorem again, but I think that's a lot easier. Now, these are the numbers that we just figured out. Let's compare the ratios. Ratios, you have to make a fraction, comparing two numbers. Compare the ratios of the corresponding sides. So what are the ratios for the sides AB prime to AB? So the new image to the original. What is AB prime? 6. So I have 6 to what? What's AB? 3. What does that equal? You simplify. 2 to 1, or just 2, right? How about BC prime to BC? What's that one? BC prime to BC. What does that equal?
4, 2.
2 again, isn't it? What is AC prime to AC? That again equals 2 to 1 or 2. So what does that tell us from our beginning in our ratio, a comparison of two numbers using division, written as A to B, A to B, A to B. Proportional relationship, corresponding ratios that are equal. So those tell me that corresponding line segments and figures are proportional. Are they all proportional? They all equal what? The ratio of each pair of corresponding sides is equal to 2. So therefore, the corresponding sides have proportional lengths. Because they all equal 2, therefore they are proportional. Example 2. Let's determine whether triangle ABC is similar to DEF. Similarity can be proven using transformations. ABC maps to DEF using transformations with a blank. Then the triangles are what? With a, yep, because down here a dilation took place. Then the triangles are what? Are they congruent in a dilation? No, they're same shape, but they're not the same size, so they are what? Similar. Describe the series of transformations that map the pre-image ABC to DEF. So what do we have to do? What do we have to do to get from here to here? That's the first thing I need to do to my pre-image. What do you think? What do you want to do to this image to transform it to that image? Translate, reflect, or dilate?
Dilate first.
You want to reflect it? You want it to look like... Oops, I forgot mine. I put my origin on it. There we go. Now let's try it. Is this what you want to do? What do you think? Does that match? Because here's my right angle. Now here's my right angle. What do you think?
No.
You want to reflect it first? Reflect it over the what? Reflect it over the y-axis. So we'll reflect it over the y-axis. Then I want to do what? Darren.
Then translate.
Then,
Dilate.
yep. What do you want to dilate it by? What are we going to dilate it by? Are we going to dilate it by a number bigger, greater than 1, or less than 1? What do you think this is going to be? If you look at this side, how many units is this one? 1, 2, 3, 4. What's this one? 1, 2. So what did they do to the sides if they're proportional? They'll dilate it by what? Less than 1. So what are we going to do to get it from 4 to 2? Take it times what? 1/2. So we're dilating it by a scale of what? 1/2. There you have it. Take all the images, all the ordered pairs, multiply them by 1/2. This side's 4. This side's what? 1, 2, 3, 4, 5, 6. This side's 1, 2, 3. Perfect. Proportional. How about this one? Explain what you want to do. Order. What do you want to do first? Translate, reflect, or dilate? Reflect? Reflect over the what? Is that a reflection over the y? Is that what you're thinking? And then dilate it? Is that what you're thinking? Reflection over the what? Y-axis. And then dilate it by what? Is it going to be a number less than or greater than 1? Greater than 1? Okay, what are you going to multiply by? The original is what? 1, 2, 3 units long, and what is it? what is this one? 1, 2, 3, 4, 5, 6.
Times 2.
So a scale of what? 2 or 3? I'm hearing both. Do I want to take 3 times 2 or 3 times 3?
2.
2. So this will have a dilation then of a scale of 2. There you have it. Are they proportional? Let's check our sides. Are they proportional? Here we have 3 to 6. What is this side? 1, 2, 3, 4, 5. So if this is proportional, 3 to 6, that has to equal 5 to, what does this one have to be in order for it to be proportional? This side's 5. What does this one have to be if you said a scale factor of 2? 5 times 2 is 10. Is this 10? 1, 2, 3, 4, 6, 7, 8, 9, 10. Because what do they both simplify to? 1/2, 1/2. Or if you've been taught this way, 10 times 3 is 30. 6 times 5 is 30. They're equal. They are proportional. Last one. What do you want to do first? Reflect it over the x-axis?
Rotate.
Rotate or reflect? Because we're looking at this one. If we rotate it, it would be right there. That's looking kind of nice, isn't it? What if we reflect it? You said reflect it in the what? The x or the y? Or either? That one? Or that one? What are you thinking?
Rotate.
I think rotate in order to get it up here into this quadrant, right? Because if we reflect it, we're going to be here. And you have to reflect it again and whatnot. So we don't want to do that. So I think our rotation is probably looking the best right now. We rotate it. Rotate it what? I need some details.
Counterclockwise.
So, yep, perfect. So rotate 180 degrees. Then what? Dilate greater than 1. What's our scale factor, do you think, going to be on this one? We have to go from what? 1, 2 to how many? 1, 2, 3, 4. Scale factor of 2. You are correct. You enlarge that. If you take each of these coordinates times 2, new dilation matches perfectly. All right. So you can start your homework pages 10, 11, and 12, and 13. So 4 pages. There's lots of graphs on there. It's not as bad as it seems, but pages 10 through 13 due tomorrow.